Okay, let's get started today. We are going to be talking about database design for the next 2 weeks. And we're going to start today with the entity relationship model, which is a top-down design technique. Next week we'll start into normalization, which is a bottom-up design technique. In each case, we're going to spend 2 days on each technique. The first day we're going over the concepts behind the technique. The second day we're going to go over a case study. So Tuesday we'll go over a case study with the entity relationship model, and on a week from Tuesday we'll go over a case study with normalization. Now, just so you all know, next Thursday, which is September 25th, I believe, there is no class because I will be out of town. However, there will be a video lecture that you will be expected to watch. And basically, I'm just going to upload my videotape lecture from last year. So you will be expected to view that video lecture, which I will ensure is posted by the time I take off. And you should have viewed that by the time you come to class the following Tuesday. So no class next Thursday, but there is a video lecture. Okay. Also, I just saw before class, I had Thursday and Tuesdays are very busy days, so I don't get to my email usually until right before or after class. I saw several questions on Piazza. I don't know whether they've been answered or not, so I'll answer them quickly here. One question concerned problem 7.11 in the book. Question was, I know that MySQL doesn't enforce these constraints, but it will syntactically check them. Does that mean it will allow an invalid tuple to be inserted into a relation? The answer is yes. You cannot check whether your constraint is working by simply inserting an invalid tuple into the relation. MySQL will not check the constraint, but it will tell you if it's syntactically incorrect. If you want to check to see whether the constraint would work, you just have to test the query separately and make sure that it performs the way you think it's performing. So for example, if you're doing the double booking constraint that says that there should be no double bookings, you can run a query where you check to see whether not exists something and make sure that you either get a true or false answer based on whether or not there are double bookings in the database. Another question, let's see, question 8, whether you could create a view, and the answer is you certainly can create a view for question 8, but it's unnecessary, and it's very similar to another problem we went over in class. If you go and look at the subquery slides, you will see it's very similar to that problem. So you're probably making it too complicated if you're using a subquery on question 8. And on question 8, I also got a question about why there might be only one result, such as you might just get B003 1.00. There's two reasons. One is it is the correct answer because there's very little test data. You should actually go ahead and put more test data into the dream home relations because it may be the case that this is not the correct answer and the query is succeeding for another reason. And another reason would be, here's one way that is not correct to solve question 8. You might try select branch number and let's say count star minus, actually do it like this, let's see. do, whoops, n dot count minus average of n dot count from branch, actually from n, where, I'm trying to get this right, I'm going to be slightly off, I'm afraid, but something like where there's a subquery. I know I'm getting this slightly wrong. I can't reproduce it exactly from memory, but it's something like this. And this produces an answer that looks right, but is actually wrong. Okay, and the reason it's wrong is that it's in regular SQL, this would actually create an error. It would give you an error. And the reason is that it would first evaluate the subquery, which is this, and it would come up with a relation that might be, for example, B0032, B0051, B0071, and that would be n. Okay, and now it would apply this query to this computed result. Well, does anyone remember why this is an error? Why this is an invalid query? It's an aggregate. It contains an aggregate, but it also contains an additional attribute, which is not in the group by clause, in any group by clause. And you all might say, well, wait a minute, there it is. It's right down there in the group by clause. No, it's not. It was in the group by clause for the subquery. The subquery has now been evaluated and has yielded this result. Okay? You have no group by clause in the outer query. And since there's no group by clause in the outer query, this is an invalid query according to the SQL standard. MySQL does evaluate it, and what happens is it simply finds the average, and then it takes the very first tuple in the relation, which just so happens to be B0032. But if that tuple instead had been B0071, you would get the wrong answer and you'd realize that your query was wrong. That's why I'm saying you really need to put more test data into your relations to make sure that several branches, at least two, get returned by the actual query, so you know that it really is a correctly functioning query as opposed to one that happens to be, just through dumb luck, returning an answer that looks right but is in fact wrong. Does everyone understand why branch number is really not part of the group by clause the way you might think it is? That it's in the outer query, not in the subquery? Okay. So this won't work. You have to do it another way. Remember, as a hint, look into the subquery slides. It has an example. The other thing I've been getting a bunch of questions about is the double booking and guest booking, not allowing a guest to book 2 rooms simultaneously. I want to just say, first of all, you're going to have to join the booking relation with itself, okay, in order to get those 2. The second thing is, in each case, when you join the booking relation with itself, you're going to get some false positives. So let's consider the case of guest overbooking, meaning the guest has booked themselves into 2 different rooms at the same time. Okay? So you could have something that looks like, let's say, Hotel 1, say room 100, 2014, say 9/13 to 2014, 9/18. Okay? So when I say a false positive, when I join the booking relationship with itself, I am going to produce a row that in effect has 2 copies of this tuple. That's going to produce a false positive because it's going to appear as though this is an overlapping reservation, okay, which is no good. Okay? So you're going to have to be able to eliminate these false positives, these so-called self-double bookings. Now, in order to do that, you're going to have to look at what separates a false positive from something that is a true overbooking situation or a true overbooking situation. Okay, so one thing you might immediately say is, well, in both cases, the date from and the date to is going to be the same. So I'm going to eliminate false positives by saying I'll eliminate all tuples where the date from and the date to is the same. Okay? But whoops. Let's say this tuple's in this booking is also in there. Okay? Well, that really is a overbooking problem. The guest has checked themselves into 2 different hotels for us at the same time. So your test for eliminating false positives by just checking for equal dates is also going to eliminate this real positive. So you can't actually check to see whether 2 dates are the same. It will eliminate false positives, but it will eliminate some actual cases of overbooking. So that doesn't work. That's where you have to think about these cases and come up with some example data. Okay? So there are the true overbooking situations are a case like this where they're in 2 different hotels with an overlapping booking, or you could actually be in the same hotel with a different room and an overlapping reservation. So in fact, your false positives, you know that your true ones are where you have an overlapping booking and either the hotel is different or the room is different. So it must be the case that a false positive is one in which you have a overlapping booking and the room and the hotel are the same. So you have to figure out how to express that condition. Okay, there is an overlapping booking and both the hotel and the room is the same. That is a false positive. Okay, you might say, well, wait a minute. What about the case where there is a genuine overlapping booking such as H01 R100 2014 915 to 2014 930. That's a genuine overbooking problem, right? I've booked the same room. It's overlapping though, but it's an overlapping booking. So you say that doesn't eliminate that particular true positive. Can anyone tell me why this is impossible? Why can't I have those two tuples in my database? For someone who's looked at the homework. For someone who's not looked at the homework, they may not know why. What was the previous constraint you had to write? Now, I know some of you have looked at the homework. What was the previous constraint? There were two. One was guest overbooking. What was the other one? Double booking. What do these tuples represent? A double booking of the same room. So your previous constraint makes these two tuples impossible. The previous constraint says there can be no double booking. So you're assured that this one situation is impossible because of the previous constraint on double booking. So you're guaranteed this situation cannot exist. The only situation that can exist is that I have an overbooking where the guest is in a different hotel or in the same hotel in a different room. That would not raise a flag with the double booking constraint. Okay, that's why we only have to check to make sure that they're in either a different room or a different hotel. So that's where you have to kind of take logic and put things together, okay? Where you figure these things out and sometimes you bring in additional information like the fact that in the previous constraint we had eliminated the only possible flaw in this logic. Okay, and I'm leaving it to you to figure out how to express that logic. But this is the kind of thing that you have to kind of think about, and also what I'm saying is it often helps to create some example data to try to see what are the cases where I really do have the guest booked into two different rooms, and what are the cases where it's just a false positive. Okay, so any questions about that? Yes?
I have a question on the average staff again, the one that you explained.
Okay, this one. Remember, I couldn't reproduce this query. This is not, I think, a valid query. I couldn't.
But the average staff, should it be calculated based on all the brands?
Yes, so you take an average, you find out what is the average staff per branch.
If it has zero staff also, that should
It's included. If it's zero, it's included in the average. Yes. Okay. Other questions? Yes, Camille. Mm-hmm. Mm-hmm. Correct. Mm-hmm. You just create it once. Mm-hmm. Probably not. That's right. In a real database system that supported create domain, they'd probably all be in one place in the code rather than grouped like with each table so that someone who needed to go in and modify it could see it quickly. But yeah, you don't need to repeat the definitions. Other questions about the homework? Okay. So it is due tonight at 11:59 p.m. So make sure you get it in. Okay. So that brings us to the topic of the day, which is the entity relationship diagrams. Okay, so the basic ideas in chapter 12 is to introduce you to the basic concepts behind entity relationship diagrams. And entity relationship diagrams aren't necessarily specific to the relational database model. You can map the design into a relational database, but it does not require that you map it into a relational model. You could also use this if you were using some other type of database like an object-oriented database. So this paradigm, this modeling paradigm, is independent of the underlying database. Okay, so the chapter, we're basically getting you used to the diagrammatic technique that's used. And there's a modeling language commonly used called the Unified Modeling Language, or UML. It's used for displaying ER diagrams. And then there's also a couple common problems that are called connection traps with ER models that we'll talk about today. So the basic concepts in the entity relationship model are entities, relationships, and attributes. And it'll turn out relationships are the things that cause foreign keys to be generated. So basically, once you've identified a relationship, you'll know that there's some kind of foreign key relationship, at least in a relational database. And the entity types are going to map to relations. The attributes are going to map to columns and relations. So, in fact, it has a very nice correspondence with the relational database. It's easy to map these things into a relational database. So, an entity type is any group of objects with the same properties, okay, and identified as having an independent existence. And then an occurrence, it's just a unique object. So, if you're thinking, if instead you were doing an object-oriented database, the entity type would be the class, and the entity occurrence would be an instance. And if you're doing a relational model, the entity type is going to be a relation, and an entity occurrence is going to be a tuple. Okay, so here's some examples of entity types. The big thing is you can have either physical ones or conceptual ones. So the physical ones are often easy to get. Things like staff, property, customer, or in our hotel scenario, hotel and guest. Those are physical things we get our hands on. But there's also conceptual things, such as in the dream home one, you might have a viewing or a property inspection or a sale. Those are kind of more conceptual in existence. There may be some physical artifact, such as a piece of paper for a sale, but in this day and age, there may be no physical artifact. For example, for a viewing, we just might enter the client's comments on an iPad, and there is no physical artifact associated with it. The same thing with a booking. The booking is typically just entered into a computer. There's no longer even a physical piece of paper representing the booking. So you can also have things that, in effect, are virtual entities. There's no physical manifestation of them, but they still exist. In an ER diagram, you use a rectangle to represent an entity, and you put the entity's name in the middle of the box centered. So very simple. So here we have two entities, one named staff, one named branch. So just a rectangle with a labeled rectangle. Okay, so very simple for entity types. And when we get to normalization, we talk a bit, well, I can just say now, when you're modeling the database, we kind of already talked about this, you would need to interview employees or whatever interested party is asking you to create the database. From those conversations, you could presumably deduce what are the entities. Looking at an organization's forms is a good way of determining entities, because oftentimes each form is going to map to an entity in your database. And then you also need to make sure that you confirm any assumptions you make with your customer, that you talk to them, make sure, are these the entity types? Have I missed something? So interviews plus an analysis of forms are the two major ways you identify entities in an organization or in a database, and also the way you identify relationships. Okay, so a relationship type is a set of meaningful associations among your entity types. Okay, and you typically will have one occurrence of each entity in the relationship. So, for example, staff member S3 belongs to branch 5. Property P05 has owner Brad Vanderzanden. Okay, those are relationships between entities. And as I say, if you have a relationship, then you will have one, at least one attribute from each of the two entities in each occurrence of that relation. In the ER model, the way relationships are diagrammetrically displayed is as a line between entities and an arrow showing the direction of the relationship. And when you're coming up with these relationships and trying to figure out which direction the arrow goes, it often helps to try to say it as a sentence like branch has staff, or staff is a member of branch. The name of the relationship is often a verb. It's not always the case, but typically a good relationship name will be a verb. And you try not to duplicate your relationship names because it becomes confusing as to which one to use. On a lot of homework assignments, I see students redundantly using has, and that's a bad habit to get into. You should have at most one, okay? And this probably, since has is so common, might not even be a good verb here. It's just the one the book used. It might be something like branch employs. Might be a better one. The direction that you choose for the arrow, notice here the arrow points towards staff. Okay? Typically, the direction of the arrow points to the entity that's going to contain the foreign key. So typically, the arrow points to the entity that will store the foreign key that represents the relationship. So in this case, if you look at the staff relation, it has an attribute called branch number, which is a foreign key that denotes this relationship that branch has staff. Each staff has a branch number identifying which branch the staff member belongs to. So that rule right there should help you decide which direction the arrow should point. And I will take off points if you don't come up with the right direction for that arrow. Okay, so questions about that? Okay, now this was a binary relationship, a relationship between two entities. But in general, you can have two or more entities participating in a relationship. And the number of participating relationships is called the degree of a relationship. The most common are binary and ternary. More rare are ones above that, such as quaternary. Okay, so here's another example. A private owner owns property for rent. And again, property for rent is going to be the one that has a foreign key indicating who owns it. So the arrow points toward property for rent. When you have higher than a binary relationship, you no longer use an arrow. You also will notice, what did I introduce into this diagram that's different from this diagram? What's new? The diamond. So if you have a relationship of degree 3 or higher, you use a diamond to represent the relationship, and the relationship name goes in the diamond. Notice again the use of the verb here. Registers as a verb. And you no longer have an arrow. So it's now undirected. So this is an example. A staff registers a client at a branch. Okay. In the hotel relation that we've been using for the homework assignment, the booking is in some sense a three-way or degree 3 relationship. A guest is booked into a room at a hotel. So that in effect, the booking is in fact a three-way relationship. So you could have in the hotel, guest books room at a hotel. And you will see that sometimes relationships end up as get mapped into a relation. So they are not an entity. However, when we end up mapping this into a relational model, we will find that sometimes relationships end up being modeled as relations. That doesn't mean you try to model that. You don't turn the booking relation into an entity in the entity relationship model. It is not an entity. It is describing a relationship among 3 other entities in our hotel. Okay? Another example, just like Mark, another example would be a staff and a client, or a staff leases a property to a client, and that also at least involves an owner. That's actually a quaternary relationship. So next slide. This is one example. A solicitor arranges a bid from a buyer for a financial institution, but another one could be a staff member leases a property to a client, okay, and that might also have to be signed by the owner. So that's a quaternary relationship. So these degree 3 and higher relationships do come up a lot. And again, I often see that's a hard one when you're a novice to really get into. It's easy to see the binary relationships and not see the ternary relationships or the quaternary relationships. Okay, now to go, Mark.
So back with the booking
Mm-hmm.
one, why couldn't booking
That's the trap. Okay, you just articulated the trap very well because it doesn't properly describe the relationship among the three. So if you create it, that's what I often see from when people are just learning the entity relationship model. They'll create booking as a separate entity. And then they'll create three binary relationships between the hotel, the room, and the guest. And that completely obscures, to someone looking at it, that completely obscures the fact that it's not three separate binary relationships, but one single relationship among those three entities. So by doing it this way, you've obscured the essential relationship among those three entities. Okay? So this I would mark down for it because this is not the proper way to describe that relationship. Correct. Yes, exactly. Some relationships end up getting modeled as a relation, but they are a relationship, not a entity. Okay, we'll see several examples of this. It turns out that multi-valued attributes typically have to be also modeled as a relation, but they're not an entity. It's just we have to, because of the restriction of the relational model, we have to use a relation to represent a multi-valued attribute. Okay, and there'll be another example. So you don't want to get into the habit of letting the underlying database, in this case the relational model, drive your thinking of how to write the diagrams. You want to design it to really express the relationships, and then if you have to, you'll map them down into relations in the underlying one. Okay, but thank you, Mark. I was actually, I hate to say it, I was trying to think how best to express this fact that often I see a bunch of binary relationships, and you articulated it perfectly. No, but it's a good question because that's it. Most of the time, these degree 3 ternary and quaternary relationships could be expressed this way, but then it doesn't really do it well. And it gets worse if it's a quaternary degree 4. It means that you actually have 4 choose 2 or 6 pairs of relationships now. So it actually blows up very quickly as you get higher degree relationships. And then it really starts obscuring the fact that there is these relationships between everything. Okay. Actually, I suppose it doesn't. I'm sorry. I'll take that back. I think you could probably do the same thing with the quaternary, which is just take the relationship, make it an entity, and give it 4 binary relationships. So I take it back. It's linear, but it's still really obscuring. Yes. Okay. What's your name? Just so I. Nash. Okay. Same thing. So, okay. Other questions? Okay. By the way, so here's a way that you can tell, okay, whether if you're getting into this trap of writing these binary relationships, the way that you could kind of perhaps realize that booking or books is really should be represented as a multi-degree relationship is if the underlying relation has multiple foreign keys. There's a good chance, remember booking does, it has multiple foreign keys, a hotel number, a guest number, and a room number. So it has multiple foreign keys. There's a good chance, it's not all the time, but if that thing has multiple foreign keys, there's a chance there's a multi-way relationship lurking there. It's not guaranteed, but you should at least consider that possibility. So you also can have so-called recursive relationships where the arrow goes to the same, back to itself. This is a recursive relationship, so it's a circular arrow. In this case, staff actually might supervise. You have a staff who supervises another staff. So in every staff entity, you might have a manager. Okay, this should be manager. And it would have a reference to itself. That's a recursive relationship. And typically when you have a recursive relationship, when you draw it diagrammetrically, you have the arrow, you show the direction, and you have each row listed. So not only do you have here the verb indicating the relationship, but you indicate also the two nouns that indicate the two roles in the relationship. So supervisor, supervises, supervisee, to make it clear what that recursive relationship is. You don't do it otherwise. So back here you didn't, back here you didn't see me listing the rows. It's only for recursive relationships back to the same one that you list the row. Okay. Now you can also get this kind of recursive relationship where it's not to itself, but it's a cycle between entities. So this is also, in some sense, a recursive relationship because it's circular. Here we have staff manages a branch. Okay, if you remember the branch relation had a manager as part of it. And the staff, of course, for each staff, there is the branch that that staff member belongs to. And here again, you probably, because you have a circular relationship, you may go ahead and list the rows so it's clear what is going on. So a manager manages a branch office. A branch officer has a member of staff. That makes it easier for someone looking at it to discern what the two relationships are. Because often when you have this type of circular relationship, if you don't label the roles, someone looking at it may be confused as to why you have the circular relationship. This makes it clear. Now, if you picked your verbs well, then you might not have to do that, but it's still, with these circular ones, typically you would label the roles as part of the relationship. So remember, relationship name, typically a verb. The roles should be nice, short nouns. Okay, so any question about relationships? We're not done with them, but that's a quick introduction to them. Yes, Subhash? Same with what? For joins queries or
for views, if there are two relationships and if some entities is linked with both the relationships, how do you
Okay, I'm still not really
For
understanding.
example, the branch also, let's say in this case it doesn't agree, but the branch can also work in some other places.
Okay, so a branch might, say, be part of a division.
Yes, something like that.
Okay, so you could have then division. Let's say that was a higher one. So a division might consist of branches. Okay, so yeah, so then you start building it up. Okay, we'll have a bigger case study on Tuesday. That kind of brings it all together. Other questions? Okay, attributes. Okay, we've beaten them to death. Okay, property of an entity. It could also be a property of a relationship type. That's important. Relationships themselves may have properties. And obviously the attribute domain, we've beaten that, a set of allowable values for an attribute. Okay, now some things we haven't quite as carefully delineated. So we have talked about simple attributes, but you may also have a composite attribute, and that's an attribute that actually can be decomposed into multiple attributes. As an example, name. You might talk about name as a composite attribute, but really it may consist of a last name, a first name, and a middle initial. So name would be considered a composite attribute. You might think, well, why not just talk about the individual attributes? Well, that's not really right. These three attributes are related. They together comprise a name. Same thing for address. An address may consist of things like a street, a city, a state, and a zip code. Okay, so those four individually are simple attributes, but conceptually they are all part of an address. So it does make sense to talk about composite attributes, attributes that are composed of multiple components. Now, a composite attribute could itself be, one of its components could itself be a composite one. So street could actually be further blown up into a number, a name, and a, what is the lane, route, road? I know there's a word for that. Don't know, anyone? Okay, but there's something when it's Main Street or Tupelo Lane or Johnson Circle. That third thing is something. I just forget off the top of my head what it is. So I'll say type. Okay, so it's not always the case that a composite attribute is simply composed of simple attributes. It may be actually built up from other composite attributes as well. And you need to list that in your entity relationship diagram so it's clear that these are a related set of attributes. Then there's an orthogonal case. So along one axis is simple and composite. Along the other axis, orthogonal, is single value versus multiple value. So if you have multiple phone numbers for a branch, that's a multi-valued attribute. If I have a test question and let's say it's a matching question with an arbitrary number of answers, that's a multi-valued attribute. The answers is a multi-valued attribute. The attribute is answer, but there's actually multiple answers, so it's a multi-valued attribute. Children is a multi-valued attribute. You could have 0 children. You might have 15 children. I know that's rare, but not impossible. Children is a multi-valued attribute. And remember, the way we had to handle multi-valued attributes in a relational model was with relations. We had to extract the multi-valued attribute out into a separate relation. So that's a second example where you end up with an entity, with a relation that's actually not an entity. It's actually a multi-valued attribute that it's representing. And then the third type of attributes are derived attributes that you're not going to explicitly represent in your database, but which is of interest to someone. So there are three kinds. Whoops, but not on that slide. Okay, there are three kinds. There are what I would call summative attributes. Okay, these you get from aggregate operations. So count, average, sum. Okay, these are attributes you might wish to have, but you don't explicitly represent. Then there are ones that are derivable from other attributes in the same relation. Okay, length of stay in the booking relation. So length of stay, length of stay is a derived attribute because it's actually equal to date to minus date from. So you can derive it from two other attributes that are in that relation. And you don't want to explicitly represent length of stay because it's redundant information and it would simply give you the opportunity to get inconsistency in your database if you updated one of the two dates and forgot to update length of stay. So derivable attributes are things you do not wish to include in your explicit underlying database because they are derivable from other information. The third type is derivable from other attributes in multiple relations. Okay, you got a taste of that on your homework assignment. Does anyone think of one thing that you did that involved a computation of attributes from two different relations? Pardon? Yes, total cost of rooms, of currently occupied rooms. You had to go through and find the cost of a room and then multiply that by something from the booking relation. So that was an example. So let's say cost of a room, total cost of a stay, I'll call it of a stay, equals length times room cost. So the room cost comes from the room relation, and the length of stay comes from the booking relation. So that's an example of an attribute derivable from attributes in multiple relations. So three different fundamental types of derived attributes. You do not represent them explicitly in the underlying relation or in the database, but you do show them in the entity relationship model. And again, we'll show you that in a moment. Okay, you know these definitions. Candidate key, minimal set of attributes that uniquely identifies each occurrence of an entity type. Primary key is the candidate key selected to uniquely identify each occurrence. We haven't actually given a formal definition to a composite key, but it's a candidate key that consists of two or more attributes. In the room relation for the hotel database, the hotel number and room number is a composite key. Okay. And here is the promised way to show all the different kinds of attributes in an entity relationship model. So they typically, if you include them, oftentimes you don't. In this course, when you do a homework assignment, we're not going to have you put the attributes into the actual diagram. One reason for that is it can get cluttered very quickly, too detailed. But if you do include them, this is the way you do it in UML notation. Notice the name of the relationship or the entity, then a horizontal line, and then the attributes. Okay? The primary key shown in braces with the name PK for primary key. If it was a composite key, then each attribute part of the primary key would have PK next to it. Okay? Here is a composite attribute. So you show the three individual attributes here under address to make it clear that they are related, even though what you will see in the underlying relation is three attributes: street, city, postcode. You won't see address, you'll see the three individual attributes, but in the entity relationship diagram, you make it clear that these are all part of a composite attribute called address. Then telephone number is a multi-valued attribute. You show it with the minimum, and maximum cardinality. So in this case, minimally, each branch has one phone number. Maximally, each branch has three. If it was children, it might be 0.15 or 0.20. Okay, and then a derived attribute. Can anyone see how you denote a derived attribute? Slash in front of it, right there, so a slash. So you typically put the derived attributes with whatever entity you think it's best placed with. Okay. With an attribute that can be derived across multiple relations, you just have to figure out which relation it's best to put it in. For example, I would probably put the cost of the total stay. Do you think the cost of a total stay should go into booking or into rooms? I think there's a clear answer. Booking. Why? Because one room could have multiple stays, right? But each booking can have only one. So if you tried to put it into room, you would end up with a multi-valued attribute that doesn't make a lot of sense, whereas in booking, each booking naturally has a cost of the stay. So usually there is a natural place to put a derived attribute. Yes? It doesn't, it typically will, a derived attribute will not appear in the underlying database. It may appear in a view, or it may be something that you simply compute when you create a report. So derived, that's a good question. So derived attributes, okay, do not appear in the physical database. Okay, they may appear in a view, or be directly computed in a report, which is a query. So directly computed in a query. Okay, do not appear in the physical database. So that should be 1.2, is may appear in a view or be directly computed in a query. Okay, any other questions about attributes? Okay, so now we're moving back to entity types. I'm kind of following what the book did, and we talk about, I'm not going to be particularly making a big point of this, but there are strong entity types and weak entity types. So strong entity types, they do not depend on the existence of some other entity type. Weak entity types do. So strong entity types are obviously physical entities, the conceptual entities we talked about before. Weak entity types are things like what I think of as multi-valued attributes. I know they would probably differ slightly, but I tend to think of that as a weak entity type, or I might think of a um, uh, multiple degree relationship in some sense as a weak entity. Now I know that's probably stretching the book's definition, but these things would not exist without some other entity type. Okay, so I think of them as weak entity types. Okay, the book has another one. A client states a preference. Okay, and this is presumably an optional set of attributes, which is why it's being placed in a separate entity rather than into the client entity. So I would say optional attributes that get separated or that get placed in a separate entity. Now, the reason the book, again, the book actually is showing this thing as an entity. Okay? In general, I prefer just to have strong entities and just show them. But this is another way, in this case, to do it. You could separate out the multi-valued attribute into a separate entity. You can separate out the optional attributes. Okay, if you did it, Mark, if you made booking an entity with 3 binary, that would turn it into a weak entity. Okay, which, as I said, I don't want to see that, but okay. Also, relationships are allowed to have attributes. So here's one: newspaper advertises property for rent. And it must have a date on which the advertisement occurred and a cost. In general, when relationships have such attributes, they will be turned into their own relation. The booking relationship I showed you earlier, the 3-way, the guest books a hotel room, that relationship would have attributes, a date from and a date to. Okay, that's an example of another relationship that has attributes. So if you had the boom, then you would have to have ... for books, and you would have date from and date to. Okay, questions about that? Okay. Moving on. So now still talking about moving into relationships again. Relationships have something called multiplicity associated with them. It refers to the number of possible occurrences of an entity type on each side of the relationship. Okay, so for example, a branch has multiple staff members. So we call that a one-to-many relationship because there's one branch but possibly many staff members. Whereas for, say, staff manages branch, There's presumably only one manager per branch, so that's a one-to-one relationship. Okay, and the third type of relationship is an end-to-end. That might be newspapers advertise as properties, because a property can be advertised in one or more newspapers, and a newspaper may advertise one or more properties. So the basic types of relationships are one-to-one, one-to-n, and end-to-end. Okay, so that's one thing. And then we also talk about the cardinality and participation in the relationship. Okay, so the participation is the minimum number of entities that may participate in the relationship, and the cardinality is the most. So we might say, for example, that a branch might have 0 to an arbitrary, let's say maybe it's 0 to 1,000 staff, whereas in that same relationship, a staff, we might say, must belong to exactly one branch. So on the staff side, the minimum, and there must be at least one branch it belongs to, and a staff would belong to at most one branch. In that same relationship, a branch could have as few as 0 and as many as 1,000 staff. If there is no limit, then you just write n. So now, if there's no limit on the number of staff, the branch may have 0 to n staff members. So participation rate is the minimum number of occurrences of an entity in the relationship. Cardinality is the maximum number of occurrences. Okay, and when you write that down on the entity relationship diagram, there's going to be one for each side of the relationship. So here's the manages. We say that a staff member may manage 0 to 1 branches. So this says a staff member may manage 0 to 1 branch, whereas a branch may have exactly one manager. Okay, must have a manager and will have at most one manager. And I think, yes. Okay, so the best way to think about it, so one thing that's often hard to know is where to put each side of this number. So the way to think about it is you put next to the relation the number of times that that attribute value may occur in the relation. Okay, so wait a minute. It's actually on the opposite. Yes, that's correct. It's the number of times I am correct. It is the number of times that that attribute may appear in the relation. So on the branch side, if you think of the manager column, a staff member, each staff value may occur either 0 times or 1 time. A staff member can't manage more than one branch. Okay, on the staff side, okay, there is one staff person can manage at most one branch. Okay, and in fact, the branch number doesn't appear on this side for the manager relationship. The attribute occurs on the branch side in this relationship. Okay, do we have one more? There. Nope. Foresees, advertises. Okay. Here's another one, which is we have a staff overseeing some properties. So each staff, if you think of each property for rent, has a staff number representing the staff person who manages it. And there can be anywhere, the number of times that a staff person could occur in here is anywhere from 0 if they don't manage any property to multiple if it manages. So for example, staff, let's say staff 11 manages, say, 3 properties. That person appears 3 times. Let's say staff 001 never manages a property, so it doesn't appear over here at all. Okay, and then we'll say that a property may or may not be assigned to a staff member, so it is possible that no one manages the property, but if someone does, there's at most one person that manages the property. Okay, and finally, an example of a many-many relationship. So newspaper advertising properties for rent. We're going to assume that each newspaper advertises at least one property and potentially many. We're going to assume that a property may not be advertised in any newspaper. If we've leased it, there's no reason to advertise it. It's only if it's actively on the market. If it's actively on the market, we may have it in multiple newspapers. Yes. So in this case, this relationship is going to get mapped to a table. It's the only way you're going to be, if that's what you're asking. It's going to have, the advertiser's relationship is going to have to get mapped to a table. But in the entity relationship diagram, you do not show it as a table. Again, do not write it. If you're beginning, you're going to have a big temptation to write it this way. You're going to want to write advertisement and you're going to want to write property. You're going to say advertisement appears in, appears in this way, appears in maybe newspaper. And then you're going to say property for rent, advertisement advertises. And you're going to try to show it as 2 relationships. And further, you're probably going to show it as 2 one-to-one relationships. You're going to say 1.1 because one advertisement can advertise one property, and that same advertisement can only, well, in this case, one advertisement could potentially occur in, no, if it's for a property, yeah, it could occur in multiple newspapers. So, this is where I'm going to get. Yes, I believe it's this way. So one-to-many. It could appear in one-to-many newspapers. And that totally obscures the fact that this, in fact, is a many-to-many relationship. So please don't write it like this. This is wrong. Okay. The way you should show it is as a many-to-many relationship. Okay. And the slide we skipped just says what I said earlier. There are many-to-many, which earlier I said was 1 to n. The book uses 1 to star. and many to many. In fact, please use, I said 1 to n, please use a star instead. That's the way I'd like to see it used. So please use a star instead of n if there's arbitrarily many. Okay. And we will finish this discussion up on Tuesday, and then we'll go into a discussion on Tuesday of a case study which is drawn from Dream Home and is discussed, I believe, in Chapter 12. So see you all on Tuesday.